Swayam Prabha. Digital India. Educated India.
Good morning. Welcome to the second lecture of this week of ongoing course on understanding and reducing greenhouse gas emissions, and we are trying to look at emission reduction through building design and construction, especially for scope 1 and 2 emissions. In this lecture today we are going to look at passive design measures. Now, what are passive design measures and why are we wanting to do that? Let us have a quick recap of previous lecture, and that will make things little clearer for us. In the previous lecture, which was the first lecture of this week, we understood the concept of thermal comfort and what are the factors which affect thermal comfort. We saw how humans interact with buildings and how buildings interact with the outdoor environment under this entire understanding of a broader domain as thermal comfort. We understood that the primary reason for which the buildings are constructed is to provide this comfort. Thermal comfort being one of the types of comfort, but the more dominant one. So, we want to provide buildings with thermal comfort, and this thermal comfort will be achieved if we design the building correctly, or we have to add external energy, we have to consume energy to provide thermal comfort. But at the end of the day, if the building has to function properly, we have to provide thermal comfort in the building. In this lecture, we are going to look at the different types of passive design strategies headwise, and then we will look at the passive heating strategies and cooling strategies. We will look at the ventilation and daylight strategies later, but this is what we are going to cover. But before I move on to that, we have to first look at what are the different steps in designing efficient buildings. Today, unfortunately, we do not follow these steps, and all we end up doing is we end up depending upon the mechanical systems, the systems which consume a lot of energy, electricity predominantly. For lighting, we do not depend upon the natural light which can be brought into the space. For ventilation, we depend upon fans and other ventilation systems and do not depend upon the natural ventilation. For thermal comfort, we depend upon HVACs. Even when it is extremely comfortable outside, the buildings tend to remain uncomfortable throughout the year, and that is because we do not follow the correct steps in designing of these efficient buildings. Let us first look at what are the different steps if we have to design efficient buildings and if we have to reduce the energy consumption, the operational energy consumption in the buildings, thereby resulting in reduction in GHG emissions. So, the first step for that is climatic study. The first step for this is climatic study. The first thing that we have to do is understand the climate. In the last slide of previous lecture, we saw psychrometric chart. So, what we have to do is we have to plot the yearly data. So, probably for every day we have to know what are the average temperatures, average relative humidities, average wind speed, the solar radiation, what is that data, and then we will know that how much of the duration in an year is going to be thermally comfortable outdoors. Now, for the remaining year, where is the data lying? So, if I have the psychrometric chart and if I plot the comfort data for any place, then I will know that okay, this is the region or this is the duration of an year where I will not need to do anything. I will not need any external support because the outdoor is comfortable. Now, beyond this, I will know okay, if I have a hot climate, if I have a warm climate, then more of my data will be coming here. I will have to deal with this data, and we already have seen how we can do that. But first we have to know what climate is it, where is the rest of the data lying. So, where is it, or is it, if it is extremely cold, then we are primarily here. So, what do we have to do to handle this? This is understanding the climate, doing a thorough climatic study. Unfortunately, if you look at the buildings worldwide, if you look at the buildings in India, we can't differentiate between the buildings, because we respond to each climate, different climates in the same manner. India has 5 climatic zones: hot, dry, composite, warm, humid, cold and moderate. If you look at commercial buildings in each of these regions, you will see the same type of buildings coming up, those similar looking glass and steel buildings. Unfortunately, they do not respond to the climatic context, and that is why these buildings have become energy guzzlers. They take up so much of energy because glass as a material will not perform in extremely hot and sunny climate. It will work extremely well in a cold climate like that of Ladakh, but not that of Jaipur. And if you look at the traditional buildings which are there, if you look at the classic examples, we will see that difference being evidently clear. We have a different type of building for hot dry, we have a different type of building in warm humid. If you go to Kerala, you will find that the buildings have ample opportunity for air to be ventilated in, huge windows, verandas which cut off the rain but allow the wind to move through in the spaces, and the buildings remain absolutely comfortable, narrow courtyards which allow ventilation to happen throughout the day and night. So, we have to first study the climate and then understand what is the requirement of the climate, go in detail over the understanding requirement of the climate. Once we have done that, that is when we will go ahead and do the site layout and understand the intershading of the buildings. Now, what happens if we are making buildings, large buildings, unfortunately like we do in these days, we do not see what is the impact going to be on the building which is immediate next to us or even within the site. A lot of times there are buildings which will either not receive sun at all or which will be in the shadow as far as wind is concerned. So, there will not be any direct natural ventilation possible by virtue of design. Naturally it was possible, but by virtue of design it is not possible. So, what we have to see is, we have to see how the blocks need to be placed so that if we need intershading, it is there, if we do not need, it is not there. When will we need more shading? When there is a lot of sun, but we need to cut off that sun. When do we not need intershading is when we have a lot of sun and we also need a lot of sun, that is in a cold climate. Based upon this climate study, we will first do the site layout and intershading. In addition to energy, at this level itself, at the second step itself, we also need to take into account the drainage, which is primary. Unfortunately, we have stopped looking at drainage as part of the larger region. We think that my problem is just this site. So, what I will have, okay, my site is like an airtight container and the water outside my boundary is not my problem. So, I will only design my drainage for the amount of water that is going to be here. Now, what about the water that is going to go on the street or the water that is going to come from the street to us? What happens to that? So, we have to be sensitive enough, sensible enough to look at all these things at the site layout level itself. Of course, it is beyond building. A lot of these things have to be discussed at the planning level, but whatever is in our capacity, we have to do at the site layout level itself. So, talking about drainage, about water, about vegetation, all of it has to be handled at the site layout. Plus, we are also talking about views. We cannot be confined in closed buildings having no connectivity with the outdoors. Humans are connected with nature and there is an intrinsic need for us to connect with nature, and that is why windows are required. Otherwise, artificial lighting makes it visually comfortable. We do not need windows otherwise. We need windows for reducing the energy that is consumed for artificial lighting, plus to connect visually with the outdoors. Even if it is a busy street outside, the users need to connect to that outdoor. All this has to be taken care of at this step, which is site layout and intershading. Then we move on to building orientation, how the building has to be placed. Different orientations have different impacts. What is the longer side facing? Do we require a lot of south side facing? Now, it also depends upon which hemisphere of earth are we in. If we are in northern hemisphere, we know that the sun predominantly comes from the southern side. If we are in the southern hemisphere, the entire concept reverses. So, depending upon our geographic location, depending upon our altitude and a lot of other factors, it will be decided how much of sun is required, and accordingly the building orientation should be fixed. Once we have fixed the building orientation, we will go on to decide the building shape, plan form. Do we need a linear building? Do we need a rectangular building? Do we need a rectangular building with a puncture in between, the courtyard open to sky? We need a square building, circular, which plan form will work? So, after fixing building orientation, we move on to steps like building plan form. Once we have decided that, and we have decided the mass that is going to be there depending upon the surface volume ratios and other things, we move on to decide the building envelope. What kind of building envelope should be there? Now, if we are talking about hot dry climate, we need to have, we just saw in the previous lecture, we need to have heavy thermal mass. If we are in extremely cold climates, then also we need heavy thermal mass, but we need a lot of sun to be brought in. Do we need to reflect rain from the surface, or do we need to shade the external surface? All that is part of building envelope. Now, here we are also deciding, so it has two components, one is design and the other one is material. Now, we might argue sometimes, if we are looking at embodied energy, we might say that we need to have less embodied energy material, but the material having less embodied energy might not be durable enough for the same purpose, or might not be having enough strength. So, we have to see what is the quality of the material, what are the properties of the material to select the right type of material for the building envelope. We may be wanting a very smooth surface for the requirement, not for aesthetic purpose, but for the functional requirement we might be needing smooth surface, while certain other times we might be needing rough surface. What are the materials that support this intent? So, this is building envelope that we design. Then we look at the fenestrations. So, this is just an extension to the building envelope, because it is very closely, fenestrations are closely connected with the envelope. So, which orientation do we want fenestrations on? Do we want it on north or south or east or west? So, we have to look at the orientation of the fenestration, we have to look at the materials which we are going to use for the fenestrations, how much fenestration should be provided. So, all that is significant, because fenestrations in today's buildings are the source of a lot of heat ingress. I am talking about India. For cold countries it is fine, but for India fenestrations are a major cause of problem. So, we have to see how much, where, what type of window fenestration has to be provided. Up till this, we are largely talking about passive design only. We are not talking about any active measure. Once we have done all the passive designing, that is when we look at the lighting systems. So, what type of lighting? So, day lighting we have already taken care of when we designed fenestrations, but now additionally supporting the lighting, artificial lighting, depending upon the purpose. If it is a university building, it is a daytime use building, we do not use the classrooms in the night. So, we have to design the classrooms for bringing in a lot of daylight, but now there could be a room which is used for audiovisual purposes, there may be presentations, projections happening. Now, in such cases we will have to provide for artificial lighting. So, that support is to be designed here. Now, it has two parts, one again design, how do you design this thing, plus you also have the equipment. So, we have the luminary that we use. So, we may be using LED or whatever type of luminary that we use. So, that is there. Then we go on to monitor the indoor environment quality, which has different factors, different components to it. So, we have the temperature, which we are trying to control and handle through these passive design measures, but we have to see how much of carbon dioxide is being produced and what ventilation rates are there, and based upon that we will decide for the system of HVAC in the last. So, we will design HVAC. First, reducing the requirement for energy through passive design, and after that further reducing the requirement for energy through selection of different systems here. Once we have done that, we would have reduced the requirement for energy significantly, probably by 50% if we design them properly from a conventional base case. So, we would have reduced it significantly, and after that we will still add one more head, which is that of on-site generation of electricity, on-site renewable energy. So, this is what we will add in the last. First is demand reduction and after that is supply. These are the steps for designing efficient buildings. Now, I am going to go over fast and quickly take you through different passive design strategies that can be employed in buildings, and they will vary. The strategies will vary for hot climates and cold climates, warm climates and cold climates, but the strategies are clubbed under building orientation, plan form. There are different design elements that we look at, roof form, fenestration, which includes arrangement, configuration, orientation, all of that, and specifics such as vegetation. We will talk about materials in later part of the course. The first, as we said, is about site layout and building relationship. So, we have to look at the vegetation which is going to be there on site, which will impact the shading. So, there will be shading on the building. There will be also views towards the green, or there may be views which will be obstructed by the trees of the available views beyond that. There will be cutting down of sun. So, whether we want that or not, we will also be looking at what is the impact of this building on the surroundings. So, there may be shading, or there may be, depending upon the choice of material, there may also be reflection which could be detrimental to the other building and the surrounding areas. We may be looking at the soft ground versus the hard ground. So, how much is the ground coverage? All that is going to come into as the first step, site layout and relationship of the building. Once we have decided that, we are talking about building orientation. So, we clearly understand that if we are talking about the warmer areas in northern hemisphere, if we have a longer axis which is facing east and west, so there we are actually looking at more heat ingress, more heat gain, because the angle of the sun, the altitude of the sun is lower in the mornings and evenings. While if we have a longer axis facing the longer side of the building facing north and south, which means that the longer axis is aligned along east and west, in that case the entire north facade is cut off from the direct sun in northern hemisphere, and for the south, since the sun is at a higher altitude, and if the building is this with small projection like a chhajja, we can cut off almost the entire sun that is coming from the south. So, depending upon where we are and what is our requirement for radiation, we will be deciding upon the building orientation first. After that, we choose plan form. Now, we have to understand the qualities of different plan forms. For example, if we have a circular plan form, we clearly know that the perimeter of the circle is smallest as compared to any other form compared to the same area that it encloses, that it provides. So, that is the reason why we would find that in warm climates, in hot climates, the buildings are designed, traditionally they are designed to be circular. You can look at bhungas from Rajasthan, you can look at the Kutch houses, they are all circular because it reduces the amount of heat that is coming in through direct solar radiation, and on top of that we add other design features such as shading and other things. So, depending upon the plan form, we will have to choose for the given climatic context. So, the square has a different capability. If we have a linear building, then which direction do we orient it to? Linear building has its own advantages. For example, if we orient it to the wind, the direction of incoming wind, the natural ventilation is better in linear buildings. It is not as good in a square building, a large square building or a circular building. So, depending upon that requirement, we will select the plan form. Once we have selected the plan form, we check the design elements that are going to be used. For example, we may be using the courtyards. In hot climates predominantly, we prefer to use courtyards. Courtyards aid in the nighttime purging, night ventilation, and if you remember the last slide of the last lecture, we saw that if the temperatures are higher and if humidity is also in moderate range, then we need to facilitate night ventilation. Now, that night ventilation will take away the heat, the walls, the surfaces of the building, they will be cooled through the cool air that will be passing through, and we have to allow the cross ventilation, and courtyards allow that. So, what type of design feature, design element is required? In hot climates, we may use courtyards, and that is why you would see that across the length and width of the country, we actually have courtyards in traditional buildings. While if we are looking at cold climates, maybe we may be looking at the greenhouse. So, this is glass, it traps the solar radiation, it helps to create a comfortable environment here. But during the night, either the surface has to be blocked by some sort of insulation, or this remains only a day use space. So, that is also a possibility. So, which design feature? So, in extremely cold climates, you would find that they often have a glazed balcony or bay windows, which bring in a lot of sun in that area, and during the night they would either block it by heavy, very heavy thick insulating curtains or some sort of covering, which will stop the heat from going from inside to outside. So, during day bringing in the radiation, during night stopping the radiation. There are features such as water bodies. So, water bodies, we clearly know that it stores the heat during the day and it radiates at night. So, kind of balancing the temperatures, but along with that it facilitates evaporative cooling. But where will it be used? This is not of much use in warm humid regions, because it is anyways humid. So, water will not facilitate much comfort, but it will be quite useful if we have it in hot dry areas, extremely hot dry areas, but the limitation is that water is scarce in hot dry areas. So, how to use it effectively so that it provides a comfortable environment. So, if you look at the architecture, traditional architecture of Middle Eastern countries, you would find that shaded water bodies, small water fountain, such elements, water elements have been provided in traditional buildings. Then we also have vegetation. So, vegetation also absorbs radiation, it cuts off the radiation by absorbing it. So, where to provide radiation, what type of radiation to provide? Now, in composite climate, where we also have extreme summer and we also have extreme winter, we may be wanting specific type of vegetation which shades during summers, absorbs the radiation during summers, and in winters it sheds its leaves and allows for the radiation to directly come to the building. So, choice of vegetation, where the vegetation has to be, is also one of the design element. Then we also have to select the roof form. If it rains heavily, then we will have the sloping roofs, but in addition to that, we will also be looking at the amount of solar radiation that comes. If we have the domical roof, we will only be having a portion of the roof being exposed to solar radiation directly at a given point of time in the day, except for when sun is absolutely above our head, it is absolutely vertical, that the entire roof will be heated and radiated, will be receiving radiation. At all other times, half of the roof will remain shaded, a large portion of the room will remain shaded and some portion will be receiving radiation. So, there is less amount of radiation as compared to the flat roof. So, you will see that in extremely cold countries where it does not rain or snow as much, we will find flat roofs. In others, we will find sloping roofs, single side sloping towards the sun's direction. In extremely hot climates, you would find domical roofs. In Middle East, the typical roof form is domical or vaulted. So, So, sometimes it is possible to create a dome, if not then we can have vault which is slightly lesser than, less performing than the domed roof, domical roof, but it still is better than the flat roof or sloping roof for a hot climate. So, depending upon the requirement again of the amount of radiation that is received and the amount of radiation that is required, we will select the types of roof plus also the precipitation that is received, the amount of rain or snow that is received. Then we come to fenestration, both arrangement and configuration and also the orientation. Now, if you look at this particular case, here we have windows on opposite side. So, there is good possibility of cross ventilation. If we have only windows provided only on one side, so if we have a room and if we have a window provided here and if we have a door which does not open all the time, but assuming it opens. So, we will have this kind of possibility for natural ventilation, and in the surrounding areas there may be eddies. In case there is only windows on opposite side or window come door on opposite side, there will be direct there will be cross ventilation only in this part of the room, and this part of the room will be devoid of any natural ventilation. So, the arrangement and configuration of windows and doors, all fenestrations in a room to a large extent determines the amount of natural ventilation that is going to take place in the building. And there are available codes, Indian codes, which clearly give us the numbers or the extent to which natural ventilation will take place due to the fenestration arrangement and configuration. And then fenestration orientation. Now, there are two factors which determine the orientation of fenestration. One is sun. So, fenestration brings in, windows often bring in a lot of solar radiation. Also, we will talk about the material for fenestration later, but considering that glass is a commonly used material for fenestration, even if glass is not there, we can open the windows and direct radiation, solar radiation will be brought inside the building only through windows. So, windows have to be oriented for sun and second for wind. Now, what is the primary factor for which the window is being designed? Plus, of course, the third factor is view, which is also significant. So, we also have to see if there is a good view which is available, maybe not favorable to sun or not favorable to wind, we may still be providing viewing window. So, based upon these three, the orientation has to be decided. South window in tropical climate of India, northern hemisphere, will with a small projection will not bring in sun, but the east window and the west window will bring in sun in the morning and evening respectively. So, we have to choose which orientation to provide, if we want to bring in sun or if we want to cut off sun. The second is wind. If we want to bring in wind or if we want to cut off wind, we have to provide it perpendicular to the wind direction or opposite to the wind direction. So, this is what will determine the orientation of the fenestration. Then we have to talk about the fenestration controls as part of the design element. So, we might be talking about the shades, we might be talking about features such as light shells which help in penetrating the light into deeper areas of the room, or we might be talking about not just horizontal projections, we might be talking about the vertical projections, the shading devices. So, these are the controls of fenestration. Even when we are providing window in a certain direction orientation, we may control the amount of light, sun that is going to come through the window. We can limit the times at which it comes, we can limit the amount in which it comes using these shading controls. Then we have talked about vegetation. So, vegetation can help in reducing the speed or increasing the speed of air. It can help in shading the building, or it could also help in privacy, the views. So, these are the factors taking into account we will provide vegetation, but we also have to see the quality of vegetation, that it is associated with increased moisture in the surrounding air. So, we have to see whether we need vegetation or we do not need vegetation for a given climatic context. Then we have strategies which are for heating. For example, some remain common: orientation, building shape. Then we have buffer spaces and double facades when we are talking about heating strategies, that is in cold countries. So, that is where you will see the traditional buildings in cold climates, they have a surrounding veranda all around. So, the space which is in the middle, in the center, that is the space which is habitable space and heated through the heat of kitchen cooking or through the human heat, the body heat. So, all that is in the center. The buffer area, which is the veranda area, is heated during the day by sun and then closed during the night to minimize the heat loss from the central space. So, that is where we are talking about double spaces and buffer spaces and double facades. We are talking about high performance window, where the windows allow radiation to come in, but block any heat loss through the window. So, we have specific windows, we will talk about the materials later, and then we are talking about window to wall area ratio on different orientations. We are talking about the insulations and the requirement for thermal mass. We are also talking about the strategies such as minimized reduced infiltration. So, these are some of the strategies for heating, and for cooling again the broader domains remain the same, but their application changes. For example, the window to wall ratio, minimal window to wall ratio is required in areas which require more of cooling. Then we might be requiring the nighttime cooling, or we might be requiring the evaporative cooling, earth ducts, where before the air is brought into the building, it is passed through heavy mass under the earth, which is at an average annual temperature throughout. We may be talking about passive ventilation and thermal mass. We may be talking about stack effect and ventilation taking out, exhausting the heat through vertical shafts or the chimneys. So, these are some of the strategies that we might be using for passive cooling. We will look at some of the advanced cooling and heating strategies, some of which I have just mentioned here in the next lecture, but largely these passive design strategies help us in designing buildings which are passively comfortable. We do not need to put in a lot of energy externally to make these buildings comfortable. They will remain comfortable throughout the year if they are designed well, and we have seen the examples throughout the world. The traditional buildings, they have remained comfortable for centuries altogether and in different seasons with the help of these passive design strategies alone. So, as a first step, we must design the buildings passively to reduce the greenhouse gas emissions, and they will work even in today's times, the modern times. How much energy will be reduced? The calculations of the impacts of these passive design strategies, we are going to look in the last week of this course. So, how to exactly calculate the reduction potential or the exact reductions that are going to accrue. With this, I close the lecture here today. Thank you very much for joining me. Tomorrow, we will be looking at the advanced passive design strategies that can be employed in buildings. Thank you. Bye-bye.